Hello learners, welcome to this course on Embedded System Design using AT89C51 microcontroller. In this tutorial, I will be describing about on how to interface a electromagnetic relay with the microcontroller. So, a electromagnetic relay is required in order to interface high power devices. If I want to control a fan which operates with 230 volt, or if I want to control a tube light which operates with 230 volt, so we can make use of this electromagnetic relays. So a relay is a electrically controllable switch. So the excitation can be given by your microcontroller, so thereby the appropriate power supply can be diverted to the appliances which work with high power. So the applications used are in industrial controls, automobiles, and in different appliances. So we have four major types of relays: SPST, SPDT, DPST, DPDT. So SPST stands for single pole, single throw, which means we can connect a single device and it has an option of open circuit and short circuit. So here I show a typical SPST switch where we have a coil. So this coil can be provided with a current, thereby it gets magnetized. A magnetic field can be induced. So depending upon the magnetic field, the switch connected between A and B can be in open circuit or short circuit. When the coil is excited, it will be in short circuit. When the coil is not excited, it will be in open circuit. So in A, I can connect the power supply. In B, I can connect the appliances. Whenever the coil is excited, the power supply can be diverted to the appliance. When the coil is not energized, then the supply to the appliances will be cut off. So thereby we can control the devices. There is another type which is called as SPDT, which is single pole double throw. So here the device can have two options. Either it can be connected in normally open condition or it can be connected in normally closed condition. So if the coil is not excited, then A and C are in open circuit. Then the terminal A is called as normally open, whereas B and C are in short circuit, which means the terminal B is called as normally closed. So before exciting a coil, terminal A is called as normally open and terminal B is called as normally closed. So we can connect the device either in normally open or in normally closed condition. If it is normally open, then whenever the coil gets excited, then power supply will be routed to the appliance. If it is connected to a normally closed condition, so by default the supply will be routed to the appliance. Whenever I energize a coil, the power supply will be cut off. Same way we have two more versions, DPST and DPDT. So DPST stands for double pole single throw. So where I can control two appliances connected to the relay. So I can connect appliance 1 to B1, appliance 2 to B2, and I can give the corresponding supply in A1 and A2 for the appliances. So by exciting the coil, both the devices can be switched on or both the devices can be switched off. In DPDT, double pole double throw, again we can connect two devices and the two devices can be connected either in normally open or normally closed condition. So A1 and A2 are normally open, B1 and B2 are normally closed. And the appropriate power supplies can be provided to your C1 and C2. So whenever we energize a coil, depending upon where it is connected, normally open or normally closed, the appliances can be switched on or switched off. So in this tutorial, I will be discussing about AT89C51 microcontroller. We are going to interface it with a relay. So the relay is going to be connected in port 2.7 and I am going to use a 12 volt bulb. So the appropriate supply is also provided to the relay through a generator. And we are going to have a switch connected to port 1.7. Whenever the switch is pressed, the relay will be activated and the power supply will be diverted to the bulb, thereby the bulb glows. So here we show a typical circuit developed in Proteus 8 simulator environment, where we have a microcontroller, AT89C51 microcontroller. So where the XTAL1 and XTAL2 are connected to the oscillator circuit. So we are going to use an oscillator frequency of 10 MHz, and the capacitors will be used for providing a stable clock frequency. And a reset circuit is connected to the reset switch of your microcontroller. So by default, this reset pin will be at logic low. Whenever the switch is closed, the reset operation will take place. And we have interfaced port 1.7 is connected to the switch. So whenever the switch is closed, port 1.7 will go to 0. So upon that state, we try to activate the relay. So here we use a single pole double throw relay. So where one end of the coil is connected to a supply, other end of the coil is connected to a microcontroller port line 2.7. So whenever I give a logic 0 to port 2.7, the current will flow through the coil, thereby magnetic field will be induced. So due to magnetic field, the connection between your power supply and the lamp can be established. So here I have connected the lamp in a normally open condition. Normally closed condition is left free. So whenever the coil gets excited, the power supply will be connected to the bulb, thereby the bulb glows. So this is the circuit which we will develop in Proteus 8 Professional, and the corresponding code embedded C program we try to write in Micro C Pro for AT51 integrated development environment. So here in the main function, first thing is I have to declare the port 1.7 as an input port, since we are connecting a switch. So that is done by port 1 dot F7 equal to 1. So if I set this value to be 1, then the corresponding port pin will be configured as an input pin. Then in a while loop, I am going to check whether the switch is pressed. If the switch is pressed, we will get port 1.F7 will be equal to 0. So in order to check it, port 1 dot F7 equal to 0. If the switch is pressed, we need to activate the relay. How to activate the relay? We have to provide logic 0 to port 2.7. So port 2.F7 is set with 0. And I retain this value for 2 seconds. After 2 seconds, again it will come and check whether the switch is pressed. If the switch is not pressed, we give port 2.F7 to be 1, which means the coil will not get excited, thereby the power supply will be cut off from the lamp. So thereby the lamp will not glow. So now let us look at the circuit which we have developed in Proteus 8. So here I show a circuit developed in Proteus 8. So here we have connected the oscillator circuit, the oscillator with 10 MHz frequency, a reset circuit connected to reset pin, and a switch connected to port 1.7. So the relay, one end of the relay is connected to port 2.7. A logic 0 to this port 2.7 will enable the 12 volt supply to go towards the lamp. Thereby the lamp will glow. Now let us look at the program written in Micro C Pro for AT51. So as I described earlier, first we initialize the port 1.7 pin to be an input pin. Then I am going to check whether the switch is pressed. If the switch is pressed, we are going to activate the relay. So once programming is done, we can build this code, thereby a hexadecimal file can be generated. Then we can go to the circuitry, import that hexadecimal file. Try to import that hexadecimal file, which is em_relay. Then set the appropriate clock frequency, press OK. So now that hexadecimal file has been imported to our circuit. Now press the play button. So right now the lamp is in off condition. So when I close the switch, the power supply will be diverted. Now you can see that the bulb is glowing. When I remove the switch, it will get turned off. Again when I close the switch, the bulb will glow, because here you can see the connection also. So when the switch is in off condition, you can see now it is connected. Now the power supply is connected to normally closed terminal. When I switch on, the switch, you can see now the power supply is connected to your bulb, that way the bulb glows. So this is how we can interface an electromagnetic relay with 89C51 microcontroller. It is very helpful for interfacing your high power devices with your microcontroller. Thanks for watching. Please subscribe for more technical learning. Thank you.